Okay, here's a first shot. Here's a first shot at let's just say a sort of UL approvable Lichtenberg device, something that's easily as safe as a table saw. Let's look at how it's built here. Everything in this area up here, this rectangle, let's look at it from the side. This rectangle, let me get over here and look at it from the side. Okay, that's looking at it from the side. Everything in this rectangle to the left is a plexiglass enclosure. These diagonal pieces on the side here are reinforcements to make a good stiff connection between the back, this is the back, and the base. And this one, of course, is between the top and the front. Now there's a few things missing here. Let's talk about the fan while we're here. This is an exhausting fan, which would be connected to a flange that would allow the use of a dryer vent to vent gases outside. Let's look at it from the top. Okay, from the top, and this is a good time to talk about the initial size of it here. This is a little exhausting fan. It's not a little cheap computer Chinese fan. It's a ULCE approved, as well as is this container, ULCSA CE approved container to house the transformer. And this area here is a plexiglass clear enclosure. It's a clear enclosure. Now let's look at it from some kind of a side view here if we can. Let's try it from this way. Okay, so the idea here is this enclosure will have some ventilation holes in the back or in the bottom, to be determined. This fan is exhausting out of the box. It's creating a vacuum in the box, pulling cool air over the transformer, through across the workpiece and out the back. So it's important that this fan be chosen to be something with a fairly high capacity. A little higher capacity than is necessary would be good. Now this is the way this opens up. Now keep in mind that there's side pieces of this enclosure. This is how you get your workpiece. You open it up, you put your workpiece in here. Okay, your workpiece sits on this area, and then you close it up. Now, at least a few initial safety things should be noted at this point. When this lid closes to this surface, an approved safety switch will have to be contacted. It's the equivalent of a foot switch in many of the designs on the web. Now, when this lid is closed, only then will you be able to energize the transformer. I do envision this as a low voltage controlled system, so the transformer housed in the enclosure here will be turned on and off through either a relay or a solid state contactor of high reliability through a number of interlock switches. One interlock switch, of course, would be here. Now, what's the size of this thing? This one, I just drew it up to be about, I drew it in metric, but it's going to be, this one's about 18 inches wide. It's about a foot deep, and it's about 8 inches high. Now those dimensions were chosen to allow a typical small board to be put in here, like perhaps a cutting board or something. I am thinking here that we could possibly think of a way to modify the basic intent of this design, in other words, get the ULCE approval, such that the entire device could be set on a tabletop if you wanted to burn a tabletop, as, what's the fellow's name? Bruce Burns. Good guy, I suspect. Anyway, so this is where it is right now. It's in a very conceptual stage, And this is sort of what we do here to get a, oh, there's 19.86. I got a dimension on it. It's sort of what we do to get a an idea on paper enough that other engineers and safety people and people are really trying to think it through and doing the math can talk about it and do some analyses on it. Now the first feedback is going to be, hey, you didn't show this detail, you didn't show that detail. True that. But they'll get there. They'll get there. So, I don't know. I think the bottom here, you know, could be a plexiglass or a Delrin, possibly on the order of a ½ inch thick. The gluing and the securement between the front, the top, and these angled pieces in the side, extremely important that they all be very, very secure. Before I forget, one thing here that really, really needs to be discussed. Lids down on this during operation, okay? There is a major component that needs to be designed, and that would be a manipulator, at least 2 manipulators, perhaps 3, that would go in through either the front or perhaps the side here, that would allow you, through a very, very insulating path, to manipulate the probes inside the box. Let's go ahead and swing that lid up. So yeah, your probes would be here. So what that would also do is to allow the probes to be swung up and out of the way when you went to touch your workpiece. And of course, because we've got at least 1 interlock, probably 3, we would be assured that the power would be cut off. Now, I guess a couple other things aren't shown here that we should probably mention briefly is, let's see if I can flip this around here. Up. Come on there. Oh, are we hung up? We may be hung up. That would be the, okay. That would be the controls. On the side of this utility box in the back, which is, the first choice here was a ULCE CSA approved moisture-proof box. The controls, I suppose, would be on the far side here. You can't see it. The side opposite this side. Let SolidWorks get up to speed with where it needs to be here. Okay, here we go. So now we can rotate it again. Yeah, the controls over here, so you would reach around the left side of the blocks to access an emergency stop switch, possibly circuit breakers, possibly a main power switch, and of course a lot of thought is typically given to things like how do you locate an interlock switch without it being able to be defeated inadvertently. Of course, if somebody wants to defeat it, they're going to defeat it, but you don't want to be able to lay your workpiece on it and defeat the interlock switch. Also here, the ventilation through here, enough holes, big holes here, to flow through the transformer area. Decent sized holes on the back of this panel, which would have a filter mechanism in front of them to keep dust from coming into the system. And those holes, the surface area of those holes would be much, much larger than this fan, so they could draw air through the system without slowing down and causing too much power draw. What am I forgetting? I get the feeling I'm forgetting some aspect of this. Yeah, well, note here, think and talk at the same time if I can do it. The hinge area here, the hinges aren't specified yet. That's all got to be mechanically well thought out. But the that's an aspect of it. And also note these big holes. I'm going to close this lid up here, and you see this giant hole here in the side, this rhombic area. That's not going to be a hole in the final design. Of course, there's going to be a plexiglass piece on the side of the lid to cover this hole and at least partially cover this structural unit here. And that's exactly what that unit is. These diagonals are to give it rigidity to the device. I know there's some things I'm forgetting to talk about, so maybe they'll come up in the comments. But that's an initial, kind of an initial rough design to be dissected, to be criticized heavily, and the very tip of the iceberg. There's so much work to do in addition to this in terms of actual design, sourcing the correct, good components that are rated properly and certified properly, and then looking at what if this happens, what if that happens, the failure mode and effects analysis kinds of issues here. So, all right, there we go.